Televisa presenta.
Please don't go, I love you so, I love you so. Please break my heart.
If someone told you that after an apple fell on a person's head, it will solve most of the problems of classical mechanics, would you probably sound like a joke? Let me tell you about it. The Newton laws of motion are a series of principles that are used to explain the motion of an object. There are three basic laws. Let's start with the first law, the inertia law. This law states that in the absence of external force, a body at resting state will always remain this way, or if it is in a state of motion at constant speed, it will continue in this state. This is known as inertia. The resting condition tells us that while there are no forces that move them, the object will remain without moving. There must be a cause, which is a net external force, for there to be a change in velocity, either in magnitude or direction. Here is an exercise that we can use to understand better the topic. Drifting space proof moves to the right with constant velocity in interstellar deep space, away from any influence to the planet and stars. If two of its thrusters were ignited simultaneously, exerting identical forces to right and left in directions shown, what will happen to the rocket's motion? You have 10 seconds to get the answer and then we're gonna check it. The answer is letter A because the two forces are the same and they cancel each other, so the rocket continues moving in the same velocity. Now the second law, known as the law of motion, is known as a fundamental law or fundamental principle of dynamics, and it states that the acceleration that a body acquires is directly proportional to the resultant applied force and inversely proportional to its mass. The force is measured in units known as newtons. There is a formula that helps us to calculate the force, which is the next one. Force is equals to mass times acceleration. Imagine that we have a grocery cart but it's empty. We don't need a lot of force to pushing it because it's empty. On the other hand, if we have a grocery cart but it's full, we need more force to push it forward. Let's review some exercise. Imagine that we have a 0.4 kg soccer ball to kick it with acceleration of 3.5 meters over second squared, and we want to calculate the force. The formula will be the next. F is equal to mass times acceleration. Force is equal to 0.4 times 3.5, and the final result is 1.4. Remember that the units are known as newtons.
We'll let you start it in the hay. With his long johns on, pub went a creeping up to the bottom to the hay.
Finally, we get to the last law, the action and reaction law. This one states that for every action force there is a corresponding reaction force, which is equal in magnitude but with an opposite direction. In colloquial terms, we refer to this law as an action-reaction law, where the force exerted is the action and the force experienced as a consequence is the reaction. If an object A exerts a force on an object B, the object B must exert a force of equal magnitude in the opposite direction on object A. Let's imagine a swimmer pushing off a pool wall. The swimmer pushes against the pool wall with her feet and accelerates in the opposite direction of her push. The wall exerts an equal and opposite force on the swimmer. In the diagram, we can see how the force acts in the object What about if we solve a little problem? A boy and a girl are skating. The boy of 60 kilograms exerts a force of 10 newtons on the girl of 40 kilograms. What is the acceleration of the girl and what is the force acting on the boy? To calculate the acceleration, we have to use the formula of the second law. Force is equals to mass times acceleration. So acceleration is equal to force over mass. 10 newtons over 40 kilograms is equal to 0.25 meters over seconds to square. And finally, the force that is acting on the boy is the same force that he applies but in the other direction. It can be right as 10 minus 10 newtons to the left.
Give it to me.